Gel electrophoresis. Gel electrophoresis is the most widely adapted technique for detecting polymorphism. In gel electrophoresis, samples are loaded into a gel and allowed to migrate in an electric field. The two gel matrices used to separate DNA molecules are agarose and polyacrylamide. Since DNA is negatively charged, the samples are loaded near the negative pole and they migrate towards the positive pole. Separation of the DNA molecules is strictly based on size. The smallest fragments move farther in the gel better than larger molecules. The polymorphism is revealed using a detection agent. Ethidium bromide dye is used to reveal RAPD polymorphisms in agarose gel electrophoresis. Silver nitrate is used to detect polymorphisms in polyacrylamide gels. This has been used for both microsatellites and AFLPs. Another option is to include a radio-labeled nucleotide during the PCR step. If this option is chosen, the gel is used to expose autoradiographic film and analyzed to uncover the polymorphism. Detecting the RFLP requires the use of southern hybridization procedure. Briefly, molecules are separated in agarose gel and transferred to the nylon membrane. A probe to sequence of interest is then hybridized to the membrane and unbound probe is removed by a series of stringent washes. The membrane is then used to expose an autoradiographic film and polymorphisms are determined by studying the film. Capillary array electrophoresis. Small DNA fragments can be separated rapidly in narrow capillaries. Heat is lost from these thin capillaries so that the molecules can be separated rapidly using high voltage. This greatly speeds the processing of DNA molecules. Recently, instruments that contain capillary arrays have reached the market. These arrays consist of 8 Beckman-Coulter or 96 applied Biosystems capillaries. These machines simultaneously introduce samples into each of the arrays and laser technology is used to detect DNA molecules. Matrix assisted laser desorption ionization time of flight mass spectrometry or MALDI-TOF MS. It is the newest procedure in use to detect microsatellite polymorphisms. Mass spectrometry involves the ionization of a molecule, accelerating the ions in an electric field and passing the ions through a magnetic field. For DNA genotyping purposes, the larger molecule travels through the magnetic field faster. MALDI-TOF is a recent improvement of mass spectrometry. The molecule to be analyzed is mixed with a matrix that does not ionize, but aids in the ionization of large molecules up to 1 lakh Daltons such as DNA. Time of flight allows for high throughput of ions. For this, PCR amplification is performed with microsatellite specific primers. It is best if the primers are located as close to the repeat as possible. This ensures that smaller molecules are amplified. The primer contains an attached biotin molecule. The product is recovered from the PCR reaction with streptavidin magnetic beads. The product is mixed with the matrix and analyzed. Both alleles of heterozygous individuals have been easily scored. In some cases, the alleles differ by a single copy of a tetranucleotide repeat.